So today we'll discuss some previous year questions that were asked in JEE Mains based on the topic that is differentiation. Okay, so based on this topic, we'll discuss some questions. So the first question is, of course, it is visible to all of you. So just let me. Okay, so here we are given and the question is to evaluate, okay, dy by dx simply. So this question was asked in 2006, although it is a very old question, but we have to discuss the concept. So we have to first identify that which type of methods we are going to use here. Okay, so as we can see clearly that it is an implicit function. Okay, so we will take the derivative in both the side. Okay, so we'll take the derivative on both the side as it is an implicit function. Okay, so here from the relation that we are given, clearly it is identified that it is an implicit function. Okay, and the way to deal with implicit function is to derivate or to take differentiation both the side. Okay, so we'll do that one. Okay, then it will be what? Okay, so now we will take um, together the terms involving dy by dx. Okay, so okay, so here okay, so before separating dy by dx, I will use one data actually. So it will be mm, just let it be there. Then we will take common outside x to the power m and y to the power n. So it will be Okay, so okay, so I can write it like this. Okay, so clearly we know that x to the power m into y to the power n is equal to what? X plus y to the power m plus n. So I can replace this one by what? X plus y to the power m plus n. Okay, so just let me write in proper step. So it will be, I can replace this one by x plus y to the power m plus n. Just I am writing the rest of things as it is. So okay, now I can cancel out this term and this term. So rest of things will be, so now I will take common, I will take the terms together involving dy by dx. Okay, so here we can clearly see that this term involves dy by dx, and in the right hand side this term involves dy by dx. So I will take dy by dx common. Okay, so it will be n by y minus m plus n 2x plus y. Okay, so it will be dy by dx, and here it will be m plus n by x plus y minus m by x. So what I will do now is to, okay, now this one will be, you will take LCM, and then it will reduce us to what? Nx minus my divided by y into x plus y. Okay, it will be nx minus my. Okay, so I can cancel out the x plus y and x plus y. Okay, so and in the numerator also we can cancel out this one and this one. Then the rest of thing, that is dy by dx, is equal to y by x. Okay, so now we'll just check our option. So here option A, okay, here option A, in option A we are given y by x. So here we got our answer as well. So this one. Okay, now we'll see some another questions. Okay, So the first question is, okay, to differentiate that, um, here we are given 126. Here we are given, okay, that is y equal to sec tan inverse x, and we have to evaluate what, dy by dx at x equal to 1. So before solving this question, I would like to write d by d theta of sec theta, okay, it will be like that. Then d by dx, okay, dy by dx, it will be what, d by, okay, dx sec tan inverse x. So here we are given 10x, tan inverse x in place of theta. Okay, so here we are given what, tan inverse x in place of theta. So we will apply the formula as it is. Okay. Then it will be what, here we are applying just chain rule. So now I will differentiate the tan inverse x. So it will be 1 by 1 plus x square. So now clearly we can see that, okay, this one will be reduces to what, x. So now dy by dx at x equal to 1. So it will be sec of tan inverse 1 will be what, pi by 4 tan inverse of 1. Okay, it is 1. So this one will be, okay, 2. Now sec pi by 4. Okay, sec pi by 4 is what? It will be 1 by root 2. So it will be, no, not like that. I have done one mistake here actually. Yes. So it will be, no, it will be root 2. Oh, 1 by, no, it will be just root 2. Sorry. Okay, this one will be, okay, it is root 2 into 1 by 2. So it will be, okay, 1 by root 2. So here we got the answer. Okay, now we'll just check our option. So option A here is correct one, that is we got, okay, 1 by root 2. Now we'll see another question, that is 127. So here x is given, okay, so here I can write x as, okay, okay, So x is given as sine inverse t and y is given as a to the power root over of cos inverse t. So I can write it as further that x a to the power sine inverse t by 2, y is written as cos inverse of t by 2. So clearly we can see that it is a parametric. Here we are going to use what? Parametric differentiation, right? So here we are going to use okay. So in parametric differentiation, what we do, just for note, we will evaluate what? Dx by dt, dy by dt, and dy by dx is nothing but what? Dy by dt into dt by dx. So we have already evaluated dy by dt and we have already evaluated dx by dt. So we will take the reciprocal. So we'll got what? Dt by dx, and then we'll multiply this one. Then we will get our required result. So clearly I will evaluate first what? Dx by dt. So I will evaluate okay, dx by dt. So it will be a to the power sine inverse t by 2 okay into okay. Okay, so here I have missed one, that is should be mm, ln a. Okay, now I have applied here. Okay, let me clearly explain how the derivative came. So before solving this one, we all know that the derivative of okay a to the power x okay, it will be a to the power x into ln a. Okay, it becomes like that. So here we are given what? Here we are given d by dt of a to the power sine inverse t by 2. So here we will apply our chain rule by assuming this one to be x. Okay, so it will be what? A to the power x into ln a. Now what we will do? We will differentiate our x with respect to t. So here we have assumed this one as x. So it will be what? Okay. Similarly, we will evaluate our. So here we evaluate what? Dx by dt. Now we will evaluate dy by dt, and here we are given y as what? A to the power cos inverse of t by 2. So it is a to the power cos inverse okay t by 2. So it will be a to the power cos inverse of t by 2 into ln a into 1. Now we'll differentiate cos inverse t by 2. So it will be Okay, so now we need what? Dy by dx. So I can write it as, okay, dy by dt by dx by dt. So I will divide this one by this one. So I will get what? So the common one will be cancel out. Okay, this one will be cancel out, this one, and this one will cancel out clearly. So I will get minus a to the power cos inverse of t by 2 divided by a to the power sin inverse of t by 2. And a to the power cos inverse t by 2 is actually this y, and this one is actually x. So we got dy by dx as this one. Okay, now we'll just check our option. Oh, sorry, we have to evaluate what? 1 plus dy by dx whole square. So we have already evaluated what? Dy by dx. Now we have to evaluate 1 plus dy by dx whole square. So it will be 1 plus y square by x square. Now it will be x square plus y square by x square. Now we'll check our option. Sorry. So clearly we can see that option option D is correct. Okay, option D is correct. Okay, so here we solved another question. Now we'll solve another question. Okay, so question number 128. Now we'll solve this one. Uh, so clearly we are given here so 128. So here we are given what? Sorry, f of x is equal to x square minus x x square plus 2x, and we have to differentiate the inverse of f. Okay, f inverse x. So before evaluating this one, we have to what? Evaluate the inverse of f of x, that is f inverse of x. Okay, so the procedure to evaluate inverse of a function is to take it equal with y. So just I am writing y equal to x square minus x divided by x square plus 2x. Now it will be what? Yx square plus 2xy equal to x square minus x, which implies that it will be so. Okay, now taking x, so clearly we are given here that x is what? Not equal to 0 neither it is equal to -2. So h x is not equal to, okay, here the x, it is not equal to 0. Okay, so the product of two terms is 0. It means what? Definitely this one will be equal to 0. It has to be. Okay, so now I will equate y plus, sorry, y minus 1 x plus 2y plus 1 to 0. Now I will write, so it will be 1 minus y. Okay, so now we'll exchange our variable. So y equal to 2x plus 1 by 1 minus x, which implies f inverse of x is 1 minus x. Now we got our f inverse x. Now we'll differentiate this one. So it will be what? Just we'll apply our formula, then it will be what? Okay, so it will be, so it will be 3 by 1 minus x square. So now we'll just check our option. So we have 3 by 1 minus x whole square. Okay, so if we carefully see our option, then option, okay, B, option here, okay, this one, option B is correct. Okay, so now we'll see another question, that is, okay, so here we are given 129, question number 129, that 129, that f dex x is here sine log x. So we have to evaluate what? We have to evaluate dy by dx, and y is equal to, here we are given y equal to f of 2x plus 3 by 3 minus 2x. Okay, so here we have to evaluate, okay, dy by dx. Then it will be, here we are given y equal to, then it will be f dex this one. Now we'll apply the chain rule. Now we'll differentiate the inside function, that is 2x plus 3 by 3 minus 2x. So it will be what? 6 minus 4x plus 4x plus 6 divided by 3 minus 2x whole square. So abdex of x, what will be the abdex x we know, and in place of x we are given 2x plus 3 by 3 minus 2x. So we'll just replace this one by, oh sorry, we'll replace x by this one. Okay, here. So it will be sine, okay, it will be this one. So we have just solved here. Now we'll just check our option. So clearly we can see that option C is correct. Okay, now we'll solve question number 130. So it will be, okay, question number 130. So here we are given, f of 0 equal to -1, f dex 0 equal to +1, and g of x, okay, and here we have to evaluate g dex, that is g dex 0 equal to, okay. So first we'll take the derivative of the function g of x, and then we'll check the value of the derivative at x equal to 0. Okay, so now d, it will be what, 2 into f of 2 f of x plus 2 into f dex 2 f of x plus 2 into 2 f dex x. Okay, so now we'll just put x equal to 0 here. So it will be 2 into f of 2 f of 0 plus 2 into f dex of 2 f of 0 plus 2 into 2 f dex 0. F dex 0 is 1 and f of 0 is -1. So here clearly you can see that if we'll put -1 in place of f of 0 and f dex 0 by 1, then it will be -1. So f of 0, it will be reduces to what? The inside value will be, the whole inside value will be 0. Okay, the whole inside value will be 0. So clearly it reduces to f of 0 into f dex 0 into 2 into, okay, f dex 0, the value of f dex 0, just let me write. So it is 2 into -1 into 1 into 2 into 1. So it will be -4. Okay, so here is solved. Another question, I will just go to the option, and option A is correct here. Now we'll solve another question, that is question number 131. Okay, question number 131. So here we are given, so here we are given that x to the power 2x minus 2 to the power x to the power x cot y minus 1 equal to 0, and we are asked here y1 equal to y x of 1 equal to what. So what we'll do here, we will separate the y and x term first. So if we'll separate, then we'll get what, cot y is equal to x to the power 2x minus 1 by 2 to the power x by x. Okay, so one thing we have to just evaluate that if we put 1 in place of x, okay, just we have to check when x is equal to 1, y equal to what. So we'll just put this here and just check. So it will be cot y equal to 0, then y will be equal to what, pi by 2. So we got the value of y here when x is equal to 1. So now we will differentiate this equation. Now we will differentiate this equation both the side. So I will get okay. Now I will differentiate. Just I have taken 2 to the left hand side. Okay, so it will be 2 into, so here it is x to the power x minus x to the power minus x. So the way to differentiate this, okay, here I have taken dy by dx. So the way to differentiate exponential function is that just I am evaluating the right hand side. So d by dx, I can write it here, right? Okay, now I will differentiate. So it will be now taking minus 1 common outside, then this one will be reduces to what, x to the power x, okay, log x plus 1, then it one will be reduces to what, x to the power minus x, and it will be minus, I have taken minus outside, then it will be plus, and it will be log x plus 1. So now just taking common, log x plus 1 minus x. Okay, now we'll just see our left hand side, that is 2 into minus cos x square y into dy by dx. So the right hand side is 2 into minus cos x square y into dy by dx is equal to 1 plus log x to the power x plus x to the power minus x. Okay, so here dy by dx will be minus 1 by 2 sine square y 1 plus log x to the power x plus x to the power minus x. And here the question is to evaluate what dy by dx, okay, at x equal to 1. Here we have to evaluate dy by dx at x equal to 1. So just I will put 1, okay, in place of x. So it will be what? And I have already evaluated that the value of y will be pi by 2 when x is equal to 1. So it will be 1, sine pi by 2 is 1, so it will be 1 into log 1 is 0, so 1 plus 0 is 1, and it is 1 plus 1, so it will be minus 1. Okay, so it will be 2, and here 2 cancel, and we'll get minus 1 as answer. Okay.